Welcome to Programming News. It is August 10, 2026. Today, we are looking at a widening gap in the AI landscape as the industry splits between high-end enterprise services and the rapid rise of open-weight models, alongside a look at the infrastructure shifts occurring in the Linux desktop ecosystem and a cautionary tale about how a single line of code can haunt a system for nearly a decade. As competition intensifies in the artificial intelligence sector, we are seeing a clear divergence in how major players approach the market. On one side, OpenAI is doubling down on high-limit, managed enterprise services. The company has announced a new tier called ChatGPT Business Premium, aimed specifically at organizations that have outgrown standard business subscriptions. This premium tier is priced at $125 a month, or $100 if billed annually, and it offers significantly more headroom for heavy users. Specifically, while standard business seats are capped at 3,000 weekly requests for GPT 5.5 thinking, the premium tier expands that limit to 15,000. Users also lose the 5-hour daily limit on certain advanced features, though it is important to note that users will still consume ChatGPT credits for some advanced functionalities even on this higher tier. This move towards specialized high-capacity enterprise tiers comes at a critical moment. As Chinese open-weight models become increasingly competitive with closed-source American services, many organizations are facing a strategic crossroads. They are now forced to weigh the convenience and seamlessness of a managed service like OpenAI's against the potential cost savings and privacy benefits of running powerful open models on their own local or private infrastructure. Meta is positioning itself to capture that second group. The company has returned to the open-weights arena with the release of Muse Glimmer, a 30 billion parameter large language model. This marks Meta's first major model release in over a year, and it is expected to be the first of two, with an open version of Muse Spark anticipated to follow. The emergence of Muse Glimmer suggests that while OpenAI is moving upmarket to capture high-spending enterprise users, Meta is focused on providing the heavy-duty, accessible models that drive local and private deployment. As the battle for AI dominance plays out in the cloud, the Linux desktop ecosystem is undergoing its own significant structural transition. We are seeing a major shift in how display protocols are handled. Cinnamon, the desktop environment used by Linux Mint, is introducing Wayland support in its upcoming 6.8 release. This change gives users the flexibility to choose between the traditional X1 ADON display server and the modern Wayland protocol. This transition is part of a broader movement across the desktop landscape. While projects like Isover and Archon are working to evolve the X1 ecosystem, including a new server written directly in assembly, there is a clear momentum toward newer standards. At the same time, the hardware requirements for these modern environments are narrowing. Debian has begun the process of phasing out support for the x86-32 architecture, signaling a move away from older, 32-bit hardware in favor of modern, 64-bit systems. This shift toward modernizing infrastructure is perhaps best illustrated by a recent cautionary tale involving a piece of technical debt that remained hidden for 8 years. It is a reminder that in complex systems, a quick fix can become a long-term liability. During a period of industry-wide layoffs and low morale, a developer identified as Walter was tasked with a critical migration, upgrading systems from Python 2 to Python 3 following a Linux version update. When a portion of the infrastructure proved incompatible with the new Python version, Walter implemented a workaround to keep the system running without triggering immediate alerts. The solution was a simple symbolic link that pointed the Python 3 command directly to the Python 2 binary. This hack successfully masked the incompatibility, allowing the system to function and pass basic checks. The workaround was eventually absorbed into an Ansible playbook and survived through multiple subsequent migrations. However, the debt eventually came due. When a company attempted a major Linux system upgrade, the rogue symbolic link caused the process to stall, revealing a problem that had been dormant for nearly a decade. It serves as a stark example for sysadmins and developers alike. The shortcuts taken to bypass a difficult migration can resurface during the most critical moments of system maintenance. Whether it's a massive new data center in Inner Mongolia designed to house 1 million GPUs, or a simple Symlink hack from 8 years ago, the scale of modern computing is increasingly defined by how we manage complexity.